All right, if you're a product manager and you're staring down the barrel of an AI project, this is for you. We're going to break down supervised learning. Why? Because let's be real, it's the most common type of machine learning you're going to run into, period. By the time we're done here, you'll have the mental toolkit you need to lead those projects with confidence and, actually make sure they deliver something valuable. So let's get into it.
And this quote, man, this right here gets to the absolute heart of the matter for us as PMs. You can have a model that's technically perfect, like 99% accurate, a masterpiece. But if it's not actually solving the right problem, then who cares? It's a waste of time and money. Our entire job, really, is to be that bridge between the cool tech and the real-world business value.
So that's exactly what this explainer is all about. We want to arm you with the right framework, the right vocabulary, so that you can walk into any AI project and make sure everyone is laser-focused on solving the right problem. The one that actually moves the needle for your users and for the business.
All right, first things first. We have to start with the fundamentals. Let's get super clear on what we even mean when we say supervised learning.
Okay, so the key word here is supervised, and it's there for a really good reason. I want you to think of it like this. You're basically a teacher for the algorithm. You give it a huge textbook full of practice problems. These are your inputs. But here's the catch. You also give it the answer key. Those answers are the labels. The algorithm makes a guess, you show it the right answer, it corrects itself. You do this thousands, maybe millions of times until it finally learns the pattern and can figure out the answers on its own. So supervised learning really boils down to two main flavors. First up, on the left, you've got classification. This is all about putting things into buckets. Is this email spam or not spam? Is this customer a churn risk or are they safe? The answer is a distinct category. Then on the right, we have regression. This is all about predicting a number. How much will we sell next quarter? What's the price of this house? It's not about a category, it's about predicting a specific value on a spectrum.
And look, this isn't just some abstract theoretical stuff. It's literally all around you every single day. That notification from your bank about a suspicious transaction, that's a classification model screaming fraud or not fraud. Or think about when you finish a show and another one instantly pops up. That's probably a regression model that predicted a high ranking for what you'd want to watch next. It's all just supervised learning humming away in the background.
Okay, so we've got the what down. Now let's get into the how. How does one of these ideas go from a whiteboard sketch to a real, live feature in your product? Let's walk through the whole life cycle.
And here it is, the whole roadmap from A to Z. It all starts with you defining the problem. Then it's all about the data, getting it, cleaning it up, splitting it. Then the magic happens. You select features, train the model, and then you have to evaluate it to see if it's any good. And finally, the big one. You deploy it and have to keep an eye on it.
Now, here's what's so important for you to get. The data scientists, they live and breathe in the middle of this process, steps 3 through 6. But you, as the PM, you own the bookends. You are absolutely essential at the very beginning and the very end. You own the why in step 1. You're critical for defining the data needs in step 2. And you're the one who makes sure it actually gets into the product and works in step 7. That's where you make or break the project.
Okay, you're going to hear your data scientists talk a lot about splitting the data. And this is super, super important. Why? Well, think about it like this. You wouldn't give a student the exact same questions on the final exam that you gave them for homework, right? It's the same idea. The model does its homework on that big 60% training set. It sort of crams for the test using the 20% validation set to tweak things. But the final exam, that's the 20% test set. This is data the model has never, ever seen before. If it does well here, you know it's actually learned something and isn't just memorizing.
All right, so we've defined our problem, we have a process to build a model. But how do we actually know if it's any good? This is where things get really interesting, because as a PM, you have to be bilingual. You have to speak the language of the model, and you have to speak the language of the business.
See, your data science team is going to be obsessed with model metrics. They'll be talking about things like accuracy, precision, and recall. That's how they measure if the model is technically sound. But your job, your entire focus, is to translate that into business metrics. It's great that the model has high precision, but what does that mean? It means we saved X dollars by preventing fraud. It's not just about the model's performance, it's about its impact.
And this is where you, as the PM, really earned your paycheck. Because choosing between these model metrics is actually a business decision disguised as a technical one. Let's stick with the fraud example. If you tell the team to optimize for precision, you're saying, I absolutely cannot stand false positives. You don't want to block a good customer's transaction. That's a terrible user experience. But if you optimize for recall, you're saying, I cannot afford to miss a single fraudulent charge.
You don't want those false negatives. One is about user friction, the other is about financial loss. Which mistake is worse? That's not a data science question. That's a business question, and you have to answer it. So this whole conversation about trade-offs leads us right to one of the most critical parts of any successful AI project, the dance between the product manager and the data scientist. It has to be a partnership. So let's get really clear on who owns what.
I love this breakdown because it's so clear. Think of it this way. You, the PM, you own the why. Why are we building this? What's the business problem? How will we measure success? And ultimately, you make the call on whether this thing ships. The data scientist, on the other hand, owns the how. They're the experts on which model to use, how to wrangle the data into features, and how to build the whole technical pipeline. It is not a handoff. It's a constant collaboration.
All right, let's bring it all home. We've covered a lot, so let's map out what your journey looks like as you go from a complete novice to a total expert in this space.
First, let's talk about the common pitfalls, the landmines you want to avoid. It is so easy to get caught up in the hype and think AI is the answer to everything. Newsflash, sometimes a simple if this then that rule is all you need, and it's way cheaper and faster. And probably the #1 mistake I see PMs make is completely ignoring the cost and hassle of getting good, clean, labeled data. Remember that teacher analogy? If your answer key is full of mistakes, your model is going to learn the wrong things. Garbage in, garbage out. That's on you.
And here's your roadmap to mastery. This is how you level up. You're a novice when you can just tell the difference between classification and regression. You're a practitioner when you can actually look at a problem and say, that's a classification problem, and we'll need this kind of labeled data. You become an expert when you can confidently lead that tough conversation about precision versus recall. And you're elite? Well, you're elite when you can run the whole show, from writing the spec to shipping the final product.
So what's the big takeaway here? It's this. The next time someone on your team throws out the idea, hey, we should use AI for this, you're not just going to nod along. You're going to be the one asking the smart questions. Is this a classification problem or a regression problem? What's our plan for getting high-quality labeled data? And the most important question of all, how will we know if we've succeeded? Not in building a model, but in solving a real problem for our business. Answering that is how you create real impact.